Okay, in this video I'm going to show you how to find percent composition of elements in a compound. Right here is your equation for finding percent composition. What you have is you take the mass of the element in the compound over the molar mass of the whole compound. Kind of like if you were to find the percent composition of sophomores in our class, you would need to know the number of sophomores in the class over the total number of students in the class. So we're going to start out with this first example where we're going to find percent composition of copper 1 sulfide, and here's the formula, Cu2S. So your very first step that you need to do to solve this problem is to find the molar mass of the compound. We list out our elements that are in it, so we have our copper and we have our sulfur. When I take my inventory, there's 2 copper, there's 1 sulfur. Using my periodic table, I'm going to find each individual molar mass. Copper is 63.55 grams per mole. Sulfur is 32.07 grams per mole. Your next step is to multiply it out and add them together. When you do that, you get a grand total of 159.17 grams per mole. Now we have all of our information that we need to find the percent composition of each element. By setting up your molar mass this way, you do a lot of the work that you need in the next step. What I do next is I like to list out percent, followed by the element I'm solving for, in this case copper. So I'm figuring out of this compound how much of it is the copper, and then I'll solve for how much of it is the sulfur. Again, it's the mass of the element over the molar mass of the compound. The mass of my element, I have 2 of them. Multiply it by each of their individual masses, so the 63.55. That will be over the mass of the compound, which is the 159.17 grams per mole. The last step is to change it to a percent. We do that by multiplying by 100. When you put this into your calculator, you do not put percent into the formula. You don't put percent into the formula, you just think of it as a unit. So your grams per mole eliminate, do your division, multiply it out, and you get an answer of 79.85% copper. Now we're going to solve for percent sulfur, so we do our percent S. To do that, we take the number of sulfur we have, which is 1, times its individual mass of 32.07. We then divide by the molar mass of 159.17. So a lot of the setup is the same, and that the molar mass will stay the same. The only difference between them is we substitute out with our copper, and in this case our sulfur. So when I work it out, you get 20.15% O. Excuse me, not O, but sulfur. So percent sulfur. A way to check yourself is these should add up to 100%. Sometimes due to rounding of the molar masses, it's not quite 100%. It's about 99 to 101%. If you get somewhere between that, you've done the problem correctly. Okay. The next example we'll look at is this one here with the magnesium nitrate. So you're finding the percent of each of those individual elements. So for percent magnesium, percent nitrogen, and percent oxygen. So before I can go any further, I need to have the molar mass of each of these individual elements, along with the molar mass of the compound. So if we break our compound apart, and I'm just going to show that over in this space here, I have Mg, I have 1 of them. Nitrogen, I have 2. Oxygen, there are 6. Using my periodic table, I look up each of their masses. Magnesium is 24.31, nitrogen is 14.01, and oxygen rounds to 16. So I multiply and add them up. The molar mass of the compound is the 148.33. Now I have all my information that I need to now start working on my percent of each element. So magnesium, I'm just going to take this information from right here, so 1 times its molar mass over the molar mass of the compound, which is the 148.33. Nitrogen, we have 2 of them, so I'm going to take 2 times my molar mass of 14.01 over the molar mass of the compound, the 148.33. I'll show you the shortcut on how to find oxygen here in a second. So again, the last thing we'll do here is multiply these out by 100. So when I run my magnesium by taking 1 times 24.31, dividing by 148.33, hit enter on my calculator, then I will times by 100. Again, you're not putting the percent sign in. Again, you're just typing in the 100. When I do that, you get 16.39% Mg. Working my nitrogen through, I take 2 times its mass of 14.01, divide by the 148.33, and again times that by 100. That gives me 18.89% nitrogen. So we know all percentages add up to 100, so you can, like in this problem, work out each element, and we can work out oxygen just like this. The other way or other method that you can use to solve this is take 100 minus our percentages. So I'm going to minus magnesium's percent and nitrogen's. When I subtract those out, I get an answer of 64.72% oxygen. So again, if you prefer, you could set up oxygen just like this, substituting in its information and get the percent. So there are 2 different ways that you can solve that. The other thing that we learned with percent composition is how to find percent composition of something that's a hydrate. And a hydrate means that it's a solid that has water bound within the atom and within the structure of it. So this one has a very similar setup, but it also has a slight different spin on what you need to do to solve it. So what you need to do first is find calcium chloride, and we need to find its molar mass. So we have Ca and Cl. There's 1 Ca, 2 chlorine. Again, using my periodic table, I find calcium is 40.08 and chlorine is 35.45. By multiplying and adding it up, I get an answer of 110.98 grams a mole. Now I need to take care of the water. So water is the H2O. There's 2 hydrogen, 1 oxygen. Hydrogen rounds off to 1. Oxygen rounds up to 16. So when I multiply and add it up, I get 18 grams per mole. Okay. So on the previous side, we were finding the percent of each individual element. On this particular side, we're figuring out how much of this compound is the water. So we're finding percent H2O. The setup is pretty similar, so the first thing that you're going to do is take the mass of the water. What we have here, again, just like in balancing, we have a coefficient that tells us how many water molecules there are. So for every one of these, there's 2 H2O. So when you look at your other formulas, you can see the coefficient changes depending on the compound. So what I'm going to do next to account for that is I'm going to take water's mass times 2, because there are 2 H2Os. So 2 times 18 is 36. This is the top part of finding my percent water, because again, I've taken into account for the fact that there's 2 of these. So I'm going to take 2 times, oh, I already did that, so this I don't have to do that, so it's just 36. The next thing we need to do is get our grand total. So we're looking at the mass of the compound is this whole entire thing. So we take the molar mass of the calcium chloride and add it to all of our water, the 36. So I'm going to show that up here. So I'm going to take 110.98 and add it to my 18 times my 2, so my 36. So when I add those up, I get a total molar mass of 146.98. And to make it a percent, just like before, we times by 100. So when I do my division and then multiply it out, I get 24.49% H2O. Looking at one more example, so we have barium hydroxide, octahydrate, so the octa meaning 8 waters. So the same idea, so we start out by separating them, so we have barium hydroxide. I'm going to find its molar mass, so I have barium with 1. The 2 distributes in, so that gives me 2 oxygen and 2 hydrogen. Looking up each of their masses off the periodic table, hydrogen is 1, oxygen is 16, and barium is 137.33. Multiplying and adding it up, I get a grand total of 171.33 grams per mole. Well, the water part's the same, so H2O, its molar mass will still be 18. How it's different from problem 1 into problem 2 is that my coefficient here changed. In the previous problem there was 2, so I multiplied by 2. In this problem there's 8, so I'm going to take 8 times the molar mass of water. When I do that, I get 144 grams per mole. So my percent water and my hydrate is equal to the mass of all the water, so 144 over the molar mass of the entire compound. So just like up here, I need to combine these together. So I'm going to take 171.33, add my 144, and when I do that, I get a grand total of 315.33. So I substitute that into the bottom. Multiply by 100. Doing my division and then my multiplication step, I get an answer of 45.67%, and both of these are percent water.